Hey everybody. Today we're differentiating the natural logarithm. So here's what the graph looks like, y equals ln of x. We'd like to know, at any given point x, what's the slope of the line tangent to this graph? We're going to use the definition of the natural log. Y equals ln of x just means x equals e to the y. We can differentiate this thing on the right using our knowledge of the exponential function and implicit differentiation. When I differentiate the left-hand side of x equals e to the y, I just get 1. When I differentiate the right-hand side with respect to x, I use a chain rule. I first differentiate e to the y with respect to y, I get e to the y, and then I multiply it by the derivative of that inside, dy dx is what I get. Then I solve this for dy dx, and since I want this answer to be in terms of x, I'm going to take out e to the y and replace it with x, the thing that it's equal to. Overall, I found that the derivative of the natural log of x is 1 over x. It's an important differentiation formula. It's one you should memorize. For example, let's do the derivative of x squared times the natural log of sine x. I'm going to need a product rule on this. It's x squared times the natural log of sine x. And then when I differentiate the natural log of sine x, I'm going to need a chain rule. It's a composition of functions. So here's how it goes. Differentiate the first, multiply by the second, add the first times the derivative of the second. And when I differentiate that second one, like I said, I'm going to need the chain rule. I differentiate the natural log to get 1 over what's inside, and I multiply by the derivative of what's inside. The derivative of sine x is cosine x. A few more examples. To start, let's differentiate the natural log of f of x, where f is any differentiable function. Again, it's a chain rule. I first differentiate the natural log, and I get 1 over f of x, and then I multiply by the derivative of f. Overall, I get f prime over f. That's a formula that's also useful to know here and there. Example 2. The derivative of the square root of the natural log of x plus 2. Again, it's composition. I have the square root on the outside, a natural log just inside of that, and then inside of the natural log is a third function, x plus 2. So I'm going to differentiate from the outside in. First, differentiate that square root. I get 1/2 times what's inside to the negative 1/2. And then I multiply by the derivative of what's inside, the derivative of the natural log. I differentiate that by doing 1 over what's inside of that, so 1 over x plus 2. And then I multiply by the derivative of x plus 2. But that's just 1, so we don't need to write anything for that. Finally, let's do the derivative of the natural log of x to the 5th times x minus 4 to the 9th. This is a case where it's actually easier to simplify the thing we're differentiating before we apply the derivative. Remember our log rules. The logarithm of a product is the sum of the logs, and the logarithm of something to a power is the power times the natural log of the thing. So the thing inside of brackets I can simplify and write as 5 ln x plus 9 ln x minus 4. And this is pretty easy to differentiate. I get 5 over x plus 9 over x minus 4.